Hi everyone, this lesson is for Algebra 2 students. This is day 2 of logarithms. So chapter 6, section 6.5. So let's get started here. Learning targets are evaluating powers of radicals. We're trying to do this without calculators. We're going to talk about some negative bases and also celebrating radical sports. So, all right. Starting with a warm-up, what is 8 to the 5 over 3 power? So when you're working on this problem, the key is to try to reduce all of your bases as low as you can. So like the 8, we can break that down to 2 times 4 and then 2 times 2 times 2. So you should know that 8 is actually 2 to the 3rd power. And then 5/3, that's to the, so like that, 5 over 3 power. And so what's happening here is that the 3's are going to cancel and make 1. I'm going to end up with no equal signs. 2 to the 5th power, which is equal to or equivalent to 32. And box that up. Okay. Next problem, what's the value of 25 to the 1/2 power? I mean, realistically, this is what they're asking you. They're saying, what's the square root of 25? It's 5. The way you would do that is mathematically with exponentiation is saying 25 is actually 5 squared. And this is to the 1/2 power. 2's cancel, and you're left with 5. 256 to the 3/4 power. 256 is 16 times 16. But 16 breaks down. So if I'm thinking of 16, that I'm thinking 4 times 4, which is 2 times 2, and then 2 times 2. And so that's 2 to the 4th power. So realistically, it's 16 times 16, which is 2 to the 4th times 2 to the 4th. Keep the base, add the exponents. 256 is 2 to the 8th power. Now that's 2 to the 8th power to the 3 over 4 power. Okay, and so then 4 cancels, makes 1, goes in there twice. 2 times 3 is 6, so this is 2 to the 6th power, which is up here 2 times more than 32, so that's going to be 64. The value of 625, so that's going to be 20, what is that, 5. So 625 is 5 times 125. 125 is 5 quarters, and then that then is going to be 5 times 5. So we have 1, 2, 3, 4, 4, 5. So we have 5 to the 4th power to the 1 over 4 power. 4's are going to cancel, and I get 5. Okay, cool. All right. Write your answer in exact form. So again, you can show your work on your check your work on your calculator, but we want all of the form. We want everything to try to be, without a calculator as best you can. So the first problem is 64 to the 7/6 power. And 64, again, like the previous page, is 2 to the 6th power. And so that's to the 7 over 6. 6's are going to cancel. We have 2 to the 7th power. Now remember, 2 to the 6th power is 64. So if I'm going to multiply by another 2, right, that's going to be 128. So my answer is 128. For this problem here, this one is actually 1 over 64 to the now positive 2/3 power, right? Because the negative exponent brought everything down to its inverse. So now we have 1 over 64, again, is 2 to the 6th power, and that's to the 2/3 power. 3's are going to cancel and make 2. 2 times 2 is 4. So we have 1 over 2 to the 4th power. 2 to the 4th power is 16. So this is now finally 1 over 16, and then that's the simplified form. For this problem, this is just saying opposite of whatever you get from 64 to the 3/2. So we're going to go the opposite of 64, which is 2 to the 6th power, times to the 3/2 power. 2 divides into 6 3 times. 3 times 3 is 9. So we have negative 2 to the 9th power, or the opposite of 2 to the 9th power. And so this is basically something, we know that 2 to the 7th power is 128. Another 2 is 4, 5, what is that, 256. And then another 2 is going to give us 10, 11, 5, 12. So this would be the opposite of 5, 12. And then that's your answer. For the next problem, it says write your answer in exact form. So 1024, you know, just start dividing by twos. This breaks down, so 1024, right, is, if I broke that down by 2, that's going to be 512. And we just did 512, right? 512, hold on, was 2 to the 9th power. We already know that, right? So this is actually, this value here is 2 to the 9th power, and then we have another 2. So this 1024 is actually 2 to the 10th power. Now this is where the 2/5 come in, 2 over 5 power. So reduce and cancel, 5 divides into 10 twice, 2 times 2 is 4. We have 2 to the 4th power, again, 2 times 2 is 4, times 2 is 8, times 2 is 16. This one is going to be, let's just rewrite it, 81 over 64, and there's a 2 here, all to the 3 over 2 power. Now, again, always take your values as best you can and reduce them as low as you can. So 81 is actually 9 squared. I mean, it's 3 to the 4th power. I'm not sure if that's going to help more, because I know that's 3 to the 4th power. It's also going to be 9 squared. So not sure which one is going to be the best option. You just have to try. So 81 is going to be 9 squared, and that's distributing this 3 halves, right? Don't forget you have to distribute it to both terms. So 9 squared to the 3 halves power divided by 64, which I'm going to call 8 squared, to the positive 3 halves power. 2's are going to cancel, and 2's are going to cancel here. So what I have is 9 to the 3rd power over 8 to the 3rd power. And you can just leave it like that unless you want to multiply it out. Now, again, answer in exact form. Answer is a fraction if necessary. Show your work. You can always check your work on a calculator and plug the values in. If you were doing that, you would do something like this. You would go to, depends on which calculator, of course, that you have. If I have the TI-84, I'm going to go 256 to the, like that. Then you're going to see parenthesis, and then you're going to go 3 divided by 4. If you have the TI Inspire, you're just going to type that in like that. But again, you're going to have to show your work. So 256 is actually 16 squared. So 16 to the 2nd power to the 3 over 4 power. See, and that really I didn't lose my base. I didn't lose the 4. So I might have to redo that. So like 2 divides out 1. And then 2. So what I have is 16 to the 3 halves power. So I think that 16 can be brought down again, right? 16 can totally be said as 2 to the 4th power. So 2 to the 4th power to the 3 halves power. Now what that's going to do is that 2 is going to cancel in there twice. 2 times 3 is 6. So I get 2 to the 6th power. 2 to the 6th power is 64. For this problem here, we have -3/4. So again, I mean, you do have to distribute it. It's just like, when do you want to do that, right? So I'm going to just do it in the beginning. Am I? So 256, I'm going to try to do this all at the same time, I think. 256, again, we just did this. This is 2, let's see, how many 2's is that? 16 squared. So 4 and 4 is 8. Is that right? 2 to the 8th power. If that's correct, then I would say 1 over 2 to the 8th power over 625, right? That's 5 times 125. And so that's 5 5s and 1 is 6. Is that right? And so that would be, so yeah, so you just got to figure out, which one is going to be the best option for you. I think for me, I'm going to go, let's see, divided by, I'm just going to go, yeah, I'm just going to go for this one, 25 times 25. I think that's the easiest. 25 times 25, that's 5 squared, so that's 5 to the 4th. We'll just leave it at that. And then, let's see. Okay, so 5 to the 4th over this, and this is all going to be to the negative 3/4. So remember, when you do that, this parenthesis now becomes to the positive 3/4. So that when I distribute that 3/4, this will be times 3/4 here, and then times 3/4 here. And so now I have 1 over 4 canceled out with the 8 twice. That's going to be 2 to the 6th over 4's canceled. I had 5 to the 3rd power. So remember, this is 1 over 2 to the 6th divided by 5/3. So we're going to multiply by the reciprocal. So now I have 5 to the 3rds over 2 to the 6th. And we know 2 to the 6th is 64. 5 to the 3rds is 5 times 5 is 25 times 5 is 125. And that definitely does not reduce. So that's done. Now this one, again, see, this is a cube root. And this is a negative sign, which means my answer is going to be negative. Just remember that so that it doesn't make you crazy figuring out squaring this, that, whatever. So again, we're going to multiply through that negative 4/3. So this is going to be 1 over, and then again, this is going to go down to the denominator, and now it's going to be positive 4/3. 125 is 5 to the 3rd, so that's 5 to the 3rd power. Negative cube root. And then this is going to be 3 to the 3rd. And so let's rewrite this as 1 over the opposite of, these are going to cancel. Ooh, these are going to cancel. That's not going to make that negative. Ooh. All right, so be careful. So this right here, watch what happens. This is what I'm saying. This is 5 to the 3rd to the 4/3 power over 3 to the 3rd to the 4/3 power. And so what happened was my 3's are canceling. So now it's not a cube root anymore. So now it's the opposite of 5 to the 4th, but that value, look at that, inside my parenthesis is not outside my parenthesis, it's inside. So that means that whatever that value is, it's like that times that times that times that, right? So it's 4 times. So what we have is 1 over negative 5 to the 4th power divided by, let's see, what do I get? 3's cancel. I get 3 to the 4th power. And so then, and this is all, yeah, outside. That's crazy. And now that's over 1. So this is going to flip. And so when I flip this, I get 3 to the 4th on top over negative 5 to the 4th on the denominator. And so that's going to be 3 to the 4th, which is 81 over, what is that, 625? Okay. And so that just gave me a negative 5 times a negative 5 times a negative 5 times a negative 5, which made positive. Nice. Okay, moving on. Write your answer in exact form. So, you know, for this one, this is just 5 squared. So that's 5 squared to the 3/2 power. 2's cancel. I get 5 to the 3rd, which is 125, minus 16. And I'm looking at this denominator here on the exponents of 4. So, I mean, I'm going to make this 2 to the 4th power as opposed to 4 squared. Because I could have, 16 is also 4 squared, right? But that didn't actually lose the, that doesn't actually lose the value on the denominator, so that's not helpful. So if you lower it as much as you can, it's always best. Okay, so then minus, and then this is 16, which is 2 to the 4th, to the 5/4. 4's are going to cancel, so minus 2 to the 5th power, so minus 32. So 125 minus 32, what do we get? 393, and that's it. For this problem here, well, this is a little bit tricky because what this is saying is you're saying 8 over 27. This is all to the negative 2 over 3 power because this 3, right, it's going to go to the bottom of that. 8 is going to be 2 to the 3rd power to the negative 2/3 power. 27 is 3 to the 3rd power to the negative 2/3 power. 3's are going to cancel. I'm going to end up with 2 to the negative 2 over 3 to the negative 2, which is going to flip because both of these are negatives, the exponents, so it's going to take the inverse. So that's now going to be 3 squared on top 2 squared on the denominator, which makes 9 over 4. All right. For this one here, this is, just a huge manipulation of numbers, honestly. 81 is 3 to the 4th power, right? So this is really 3 to the 4th power times x to the negative 4. I'm wondering if I want to split this up first. Yeah, I think I'm going to leave this here for right now. And then I'm going to divide this by this value, which is 16 to the 4th. No, 16 y to the 4th. Here we go. And then now I'm going to just, because this is a big parenthesis, right, of the negative 3 over 4. So now we have to distribute that. So that'll be 3 to the 4th to the negative 3/4 times x to the negative 4th to the negative 3/4 over 16, which is 2 to the 4th to the negative 3/4, times y to the 4th to the negative 3/4. And so what's happening here is that all these 4's are canceling, but don't lose the negative sign. Be careful with that. 4 is here, and then 4 is here. So it looks like we have 3 to the negative 3rd power. This is going to have to go on the other page, I guess. We have 3 to the negative 3rd. So I'm just going to rewrite everything. 3 to the negative 3rd times x. And this, be careful, because this is negative times negative. So now it's positive 3. Divided by, these canceled, I get 2 to the negative 3. And then this is y to the negative 3. So what that's looking at now is one more rewrite, I guess. Y to the x cubed stays here. Y to the negative 3 is moving to the top. So that's gone, that's gone. 2 to the negative 3 is moving up, so that's 8. 2 to the 3rd, it becomes 2 to the positive 3. On the bottom, 3 to the negative 3 becomes 3 to the 3rd, which is 27. And so my answer is going to be 8, and then x first. 8x cubed, y cubed, all over 27. Okay? And so for this problem here, and this is the problem that was on the previous page. I just moved it to the next page. It says simplify, and so we're going to simplify this. Yeah, it's a little bit different. So we have 64. So again, we have 64, which is 2 to the 6th power x cubed, divided by 27, which is 3. So that's going to be 3 cubed a to the negative 3rd power. And all of this here is to the negative 2/3 power. So now we just have to distribute the negative 2/3. So that'll be 2 to the 6th power times negative 2/3, and then you have x to the 3rd power to the negative 2/3 all over 3 to the 3rd power times to the negative 2/3, and then that's up top, and then you have a to the negative 3rd power to the negative 2/3. All right, so canceling these values out, this 3 actually cancels into the 6 twice, but I still have a value up there. I get 2 to the negative 4 power, and then x, 3's cancel, so I have x to the negative 2 power. On the denominator, I get, that's a 1, so that's negative 3 to the negative 2 power, and then here 3's cancel, negative negative makes positive, and so that's going to be a to the positive 2 power. All right, so now rewriting this one more time, we've got 2 to the negative 4, two more times, 2 to the 4th, x to the negative 2, that's x squared down here. See how I move it down to the denominator? It changes the sign. 3 to the negative 2 is going to be 3 squared, and a squared is going to stay down here. So the last the last answer here for this is just going to be rewriting it one last time, which was 9 on the top. 2 to the 4th, so we have 16, a squared, and then x squared. And you're done. Okay. For these ones here, this is simplify the expression by transforming the radicals to exponential form. Leave the answer in exact form as a radical or a power, but not as a decimal approximation. So they basically don't want you to use a calculator until they do. So we'll see. 88. So this is saying 88 to the 1/3 power divided by 11 to the 1/3 power. So this can be rewritten as 88 over 11 to the 1/3 power. And then 88 over 11 is 8 to the 1/3 power. And 8 is 2 to the 3rd power to the 1/3 power. 3's cancel. So my final answer is 2. Cool. Without a calculator. This one, yeah, a little bit tricky for sure. This one is saying 7 to the 9.8 divided by 7 to the 1.6. And all of this is to the 1/5 power. Now, if I was doing this, which I am, I noticed that the bases are the same. So I'm going to keep the base, and I'm going to subtract my exponents before I deal with this. So I'm going to go 9.8 minus 1.6. So that's what? 8. So this would be 7 to the 8.2 power. 8.2. 8 and 2 tenths. 82 tenths. So this is actually, let me just rewrite this again. 7 to the 82 tenths, if that's right. And then we're going to go to the 1/5 power. So this is going to be 82, 7 to the 82 over 50 power. And I know I can reduce that by 2 at least. So that's going to be 7 to the 41 divided by 25 power. I wonder what that is. I think we should check. So I'm going to get my calculator out and check that. So pausing. So yeah, I get the same answer. So even though it doesn't look nice, that's the answer. For this problem here, what we're going to do is we are going to rewrite it. And so this is going to be 81 to the, looks like 1 divided by 3rd power over 729 to the 1/5 power. On the top, 81 is 3 to the 4th power to the 1/3 power. And so actually the 3's didn't completely cancel. So what I think I want to do is I want to try to get something that has a common base so that it's going to, so this right here is fine. You get 3 to the 4/3 power. But, I mean, let's just leave it for a second and see what happens. 729, without doing this on the calculator, just doing 729 divided by 3 is 343 times 3. And then I guess, again, I'm going to divide that by 3, and I get 81. So this would be, let me rewrite this. I'm going to erase this. In doing this, I'm going to get, so 729 divides into, or breaks down to 343 times 3. 343 is going to be 3 times 81. 81 is 3 to the 4th power. So 4, 5, 6. So that's going to be 3 to the 6th power. So 3 to the 6th power to the 1/5. Okay, so if the bases are the same, again, if the bases are the same, you keep the base and subtract the exponent, right? So we're going to get 3 to the 4 over 3, subtract 6 over 5, get a common denominator, which is going to be 15. So I'm going to multiply by 5 over 5, 3 over 3. So I get 20 minus 18. So I get 3 to the 20 minus 18, which is 2 over 15. We're done. That's my answer. And I can rewrite it like this, where I've got this a 15th root of 9, 3 squared, but this is completely fine. For this problem, again, this is like an inside out problem where you go inside first. So this is 64 to the 1/3 power. I think that's a 3. Hold on, I can't see that. Yep, to the 1/3. And for me, I'm thinking, and that's to the 1/2 power then. So 64 to the 1/3. So 64 is 2 to the 6th power. So this is 2 to the 6th power to the 1/6 power. 6 is canceled because see the 3 times 2 is 6. So this one's pretty simple. That's just 2. So this one right here is kind of leading you into logs. You're supposed to use a calculator. And in using a calculator, your job is to try to figure out what value of x is and get as close as you can. So you know that, we know this. We know 3 to the 1 power is 30. We know 3 squared is 9. We know 3 to the 3rd power is, 3 times 3 is 9 times 3 is 27. And 27 is too high. So I know that my answer has to be in between here and here. So it's got to be a power between 2 and 3. So that shouldn't be that hard, right? So then you got to just start plugging values in. And that's why I call brute force. So this is going to be 3 to the what power? So you just got to start guessing. So we're going to go 3 to the, I don't know, 3 to the 2.5 power. That's 15. Not high enough, but higher than 9, of course. So we tried 2.5, and that gave us 15.6. Okay, so now let's try 3 to the 2.9, 2.8. 2.8 is 21. So 3 to the 2.8 is equal to 21.7. So let's try 3 to the 2.6. Oops. 3 to the 2.6 power gives me 17.4. Okay, so this is what you're going to be doing, trying to figure out what this value is without using a calculator. Okay. The trick is to just try to get as close and closer and closer and closer as you can. The solution is that you're actually going to log the problem because this is an exponent and a logarithm is basically an inverse of an exponent. So in doing this, you're going to take, you got to get that x out of the exponent spot. This needs to come out. By doing that, you're going to be logging both sides. So that means when I bring this out, this becomes x log 3. Now, remember, this is an equation, right? So if you log one side, you do have to log the other. So now this is going to be log 20. And then some things that you should know is, number one, there's no value down here. So that's assumed to be base 10 since our system has been base 10. Logs can have different bases. Ultimately, we're trying to find what x is. So in order to do that, now we have to divide out this log 3. So I'm going to divide by log 3 on both sides. And by doing that, and by the way, you never cancel these numbers. Even if you could cancel them, you don't cancel them. You can't. So this is a quantity. 1 times x is x. And then you're going to have log of 20. So we're going to go log 20 equals, and I'm going to divide that by log of 3. And my answer is approximately 2.726833. And if I plug that back into my calculator, let's see, 3 to the 2.726833 is like 19. X is about, so when I plug that in, right, if I plug that value in for x, I go 3 to this power, 2.7 0.26833. I'm trying to get 20. I get approximately 19.999 repeating, which is as close as I'm going to get. So, brute force, right? So again, same thing. How am I going to get 1? So your job is to, I know that you're looking at this 625 and you're thinking, wait a minute, isn't that 25 times 25, right? 25 squared, x equals 1. The problem with that is for you to be able to do anything, these bases have to be the same. Meaning, if I had 2 to the x power is equal to 2 to the 4th power, x would equal 4. But the bases aren't the same, so that wouldn't work. So what we would do is to go back, and we're going to have to use brute force, try to figure out what that is. And that's the whole position, is that you try that. And so, being said, you tried that, we're going to now move this outside, and you would go x log 625 is equal to log 1. And again, these are base 10. And notice my variable, which was an exponent, for me to pull that out, I'm actually taking its inverse, which is the log. And so to get x by its side, I have x equals log base 10 of 1 over log base 10 of 625. And again, don't cancel anything. You're just going to go log of 1, which, by the way, is 0. And this is 0 divided by log of 625. It really doesn't matter what this number is, because, right, 95, blah, 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 is 0 divided by anything is 0. So x is equal to 0. And meaning anything to the 0 power, 625 to the 0 power, is definitely going to be 1. Okay? Also introducing the letter E. What is that? So I would expect that you, if you watch the video beforehand, that you come to class with a little bit of background about what E is, E being the natural log. You've got your E, and then you've got you have a button on here that is E underneath the natural log, which means that they are inverses of each other. So, and then some people are thinking, well, what's a natural log? That's more of an ln. So we're going to be introducing all of this stuff next week, but we're going to just continue. You're going to talk about what E is. And then here's a problem here, another brute force problem. And how would I even go about solving something like this and try to figure that out and try to brainstorm? What ends up happening is this does come to the front, and because it's a natural log, okay, we are taking ln of E and also ln of 2500. And ln also is a log, but it's a natural log. Something to notice, if you type in ln of E, and I'm not saying ln, but I'm saying ln of E, if you type this into your calculator right here, you actually get 1. And so this is just 1 times that, which is 0.08t is equal to ln of 2500. And then t is equal to whatever ln of 2500 is divided by 0.08. And so we're going to go ln, let's see if I can find that. That's just ln of the value of 2500 equals, and I'm going to go divided by 0.08, and I get 97.8. Approximately t is equal to 97.8. And so what that means too, by the way, is I should be able to plug this in back into my calculator, 97.8. I should be able to plug this value back in for t right here. So if you go back to your calculator and you type in, let's see, if you type in E to the, so you go second E to the 0.08 times, so times 97.8, is that what I got? I'm going to get about 24.99. So by plugging that value in, 97.8, I didn't go far enough actually, but I get approximately 24.99.9. So close. Same thing. Just basically you're manipulating this and you're just undoing everything. So first thing I'm going to do is move that 6 over. I get 2e to the 3x plus 5, and that equals 14. I'm going to divide by 2. So now I have e to the 3x plus 5 is equal to 7. And so now we're trying to solve for x. In order to get x out of this, first it's in the exponent spot. We need to move that in front. You need to take the natural log, because the natural log is the inverse of e. And so we're going to bring that out front. We get 3x plus 5 ln, and this is like that, of e is equal to ln of 7. Ln of e, remember, ln of e is 1. And so this is going to be 3x plus 5 equals ln of 7. And then I'm going to slowly just lose all the layers. We're going to get 3x is equal to ln of 7 minus 5. Then we're going to get divide by 3, and we get x is equal to ln of 7 minus 5 all over 3. And then again, you just use your calculator and figure out what that value is. So I'm going to go ln of 7 is equal to minus 5 is equal to divided by 3, and I get about negative 1.01. So about negative 1.02. And then you can plug it back in right there for x and see, did I get the right answer? Did this work? Yes or no? Okay, it's kind of cool, right? Homework is page 251. You're going to do problems 13 to 51 odd. That's it. Try to use these without using a calculator, and be ready on Monday, Tuesday for delving into logarithms big time. All right, have a great weekend. Have a great night. Thanks for watching.